Hey everybody, so in this video, I'm going to be going over all of the JavaScript array methods that are not either deprecated or currently experimental. Now keep in mind, this video is as of February 2022, and some of these will probably be deprecated and some will probably be added in the future at some point. So just keep that in mind. But all of the ones that are currently available as of February 2022, I'll be going over every single one of them in this video. Now, I do want to say that there are some terms I kind of want to familiarize you with before we get started. One is the idea of mutation, and that is basically the idea that the array is going to be changing. The array is going to be modified in some way. So if it's not mutative, that means that the array is not, the original array that we're calling the method on is not going to change whatsoever. If it is mutative, then the original array that we're calling the method on is going to be modified in some way. The other concept I kind of want you to understand is the idea of exclusive. So in other words, it does not count. So if I say that a particular method takes an end value, and let's say the end value is 3, that means up to 3, but not including 3, exclusive of 3. So up to, but not including. You will see what I mean by that as we get into it. I just want you to keep these terms in mind as we move forward. Now, I will be moving through these as quick as possible, but timestamps will be in the description. So if you want to get to a specific array method, you can just go into the description and click on the timestamp for that specific one. Now, before we get started, if you haven't already, please like this video, subscribe, and let's go ahead and get right into it. All right, so before we get started on the first array method, I'm just going to say that I'm going to be using VS Code for this. On the top section here is where I'll be typing my code, and down here is where I'll be running my code using Node.js. Now, some of these array functions have some arguments that I'm not going to be going over in this video. If you want to see the full details of every single array method, I'm going to put a link in the description where you can go to the Mozilla documentation and see everything you could ever want to know about each of these, but I am going to go over as much as I can. So let's go ahead and start with the very first one. And starting with the first one, we're going to do reverse. Now, obviously, just by the name, you could probably tell that reverse reverses an array. This is a mutative function, so it is going to modify the original array. So let's start with an array here. And if you could probably guess, if I call the array.reverse, it's going to reverse this array, right? So let's log the result, console.log the array. And again, it's mutative, so I can just call it on the original and we should see the reversed version of this. And as you can see, 3, 2, 1 is logged down here. All right, right into number 2. So number 2, we're going to talk about push. Push is one of the very first methods you've probably learned when you learned how arrays work in JavaScript. So it'll probably be a pretty easy concept here. Creating an array of 1, 2, 3, and 4. And let's say I want to add an item to this array. Let's say I want to add the number 5. I can just use the push method for this. So I'm calling the array.push and I'm putting in 5. Now keep in mind, this is mutative. This is a mutative function. So it is going to modify the original, which means I can log the original here and see the mutated result. And the result is 1, 2, 3, 4, 5. Now this method actually accepts any number of arguments. So I can actually come in here and say 5, 6, 7, 8, 9. And when I run this, you'll see that it logs an array of 1, 2, 3, 4, 5, 6, 7, 8, 9. Now up next is unshift, and unshift is exactly the same as push, but instead of putting the item at the end of the array, it's going to put it at the beginning of the array. So if we have an array called the array that contains 1, 2, and 3, and we want to add something to the beginning, let's do what we did with the last one and say the array dot unshift 4, right? So if I were to use push, this array would become 1, 2, 3, 4. But in this case, it's going to mutate it and it is going to log 4, 1, 2, 3. That is because unshift adds the item to the beginning and not to the end. Now let's talk about includes. Includes is not going to be mutative, so it's not going to modify an array in any way. And what it's going to do is return a Boolean, true if the item that you're testing is included in the array, false if it is not. So let's create an array. Here I have an array of 1, 2, 3, 4, 5. And then here I'll be logging 2 different checks. I'm going to check whether or not it includes 4 and whether or not it includes 11. We should get true and false respectively. If I run this, you can see that it logs true and false as expected. Now you can also pass an additional argument to the includes function called findIndex. So if I get rid of these and put these in here, the first one I'm adding in a 1 as the second argument to say that I want to test if the array includes 2 from the index 1 and forward. This one is the same thing, but with index 2. So I want to check if 2 exists in the array from index 2 and forward. Now, keeping in mind that array indexes start at 0, 0, 1, and 2, on this line right here, I'm checking whether or not 3, 4, or 5 contains 2, which should be false, but the first one should be true. If I save this and log it, you will see that true and false are logged below. All right, the next one is going to be array.isArray, which is just going to test whether or not the argument given to isArray is or is not an array. It'll return true if it is an array and false if it is not an array. So here I have two different arrays. I have definitely an array, which is an array of 1, 2, 3, and then probably not an array, which is just the letter A as a string. Now I have two logs here. I'm going to log array.isArray definitely is an array, and array.isArray probably not an array. I'm going to log both of these, and as you can see, it logs true and false. So this is an array and this is not an array. Next up is array.from. So I'm creating an array here of 1, 2, and 3. And what array.from is going to do is create an array from something that you give it. So if I give array.from an actual array, what it's going to do is actually make a copy of that original array. So if I go one line below here and change or mutate new array, since it's a copy of the array should not be mutated, but new array should be mutated because new array is now a copy of the array. So I'm going to log both the array and new array just to make sure that it is the case. You can see that the first one is not mutated and the second one is mutated. So this was a copy, but we mutated the copy. The original was not. This method could actually be pretty useful in certain scenarios. For example, let's say you're editing HTML and you are adding JavaScript and you say document.getElements by class name. That's going to return something called a node list. That's not actually going to be an array. Well, you can convert that node list to an array by using array.from. And then in doing so, you can use all of the array methods on that node list. It'll make it a lot more convenient for you. Okay, so next up is going to be array.of. Array.of is pretty simple. You can pass in any number of arguments and it will take those arguments and build an array out of those. So if I say const the array equals array.of and I pass it 1 undefined, an array of 1, 2, 3 and hello world, if I log this, you will see that it logs an array of all of those items that I passed in. So that's all this does. Let's talk about indexOf. So indexOf is going to allow us to find the index of a particular value in an array. And it's going to be the very first one that it finds. So if we have an array here of names, Tyrese, Candace, Joe, and Sky, I can use indexOf to find, for example, the index of Joe. So here I am checking in console.logging names.indexOf Joe. If I run this, you will see that it says 2 because 0, 1, 2, that's correct. It is the index 2. But what if I put one in here that doesn't exist? Let's say I check for index of Billy. Well, we get -1. So if it cannot find it, it will return -1. Now, what if there's two of the same value? So let's say I put in Joe twice. Put in Joe into this array twice, and now I'm going to check for Joe, and it gives us 2 because it's the first one it found, 0, 1, 2. If we want to find the very last one, we could use lastIndexOf, which is our next one. In this case, I have an array of 1, 2, 3, 4, 5. And let's say I want to find the index of 3. Well, I could use lastIndexOf for this, although it's not necessary because there's only one reference. But let's say I did want the last index of a given item. I could use lastIndexOf here. Let's see what this logs. It logs 2 because 0, 1, 2, 3 is indeed the answer to that. So now let's add in 4, 3, 2, 1 at the end and run this again. You can see now it gives us 6. If I go 0, 1, 2, 3, 4, 5, 6, you can see 3, the very last 3 in this array has an index of 6. While if I just were to change this to regular indexOf, save and run this, we will get 2 because it finds the first. So indexOf and lastIndexOf do the exact same thing. It's just indexOf gives us the first and lastIndexOf gives us the last. Okay, let's talk about toString. So let's say I have an array of 1, 2, 3. ToString allows me to convert this array into a string representation of the array separated by commas. I'll show you what I mean right now. So let's call the array.toString. Now, if we log this, you will see that it just logs 1, 2, 3. That's because this is not mutative. It is not going to turn the array into a string. It's going to return a string representation of the array without modifying the original. So we can take this call right here and pass it into this console.log, save it, run it again, and see that it gives us a string of 1, 2, 3. However, in certain scenarios, you want to convert it to a string, but you want it to be locale specific. Now, my locale is English USA, so you're going to see English USA specific locale strings here. But we can use toLocaleString instead of toString to get locale specific strings. So I'm going to run this, and you can see that it still logs 1, 2, 3. But let's say I want to log it as currency. Well, toLocaleString, I can pass in options. I can say style is currency, and the currency I want to provide is going to be US dollars. And then here I have to provide the locale as the very first argument. And when I run this, you can see that it converts it to dollars. And you can get all of the options if you just go to the link in the description to the Mozilla documentation. So the next one we're going to talk about is join. Now join takes an array and allows you to convert it into a string, but it gives you more robust functionality over how it joins it, because you can give your own separator. So if you just call toString on an array, it's going to join it together with a comma, but let's say we don't want to join it with a comma. Well, I have an array here called the array with don't forget to subscribe inside of it. Now, if I were to call console.log theArray.join on this without providing it any arguments whatsoever, let's see what it gives us. We get don't forget to subscribe, just as if we would have called this with toString instead of join. But now we can pass in a specific separator that we want here. In my case, I'm just going to add a smiley face with an empty white space character on both sides. Save it, log it, and now you can see don't forget to subscribe with smiley faces. All right, what is the next one? We're going to talk about pop. So the array method pop. What does pop do? Well, it removes the last element from an array and then returns that item. This is mutative, so it is going to modify the original. So let's read that again. Removes the last element from the array and returns that item. So if we were to just call pop, it's going to return the item it's removing. So if I say const item equals whatever array dot pop, that variable will equal the item that the item that was removed from the array. But if we were to log that original array, that item would now be missing because it mutated it. So I'm going to plop in an array here of A, B, C, and D, and let's console.log theArray.pop. Let's just log that and see what we get. Well, we just get D because this call here actually just returns D, but let's actually log the array afterwards to see what happens to it. So logging that, this returns D. And then if we log the array, you can see that it was mutated and now D is no longer in the array. So pop just mutates the original by removing the last item from the array and returns it in the call itself. And so there's another one called shift. So let's talk about shift. Shift is the exact same thing as pop, but instead of removing the last item, it's going to remove the first item. So it is mutative. It's going to do the exact same thing that this is doing, just with the first item instead of the last item. So let's replace pop with shift, save it, see what it logs. All right, so this is returning A because it's the first item of this array. And then when we log the array, you can see that it was mutated to remove that item from the array. So shift and pop do the same thing, just kind of on the opposite sides of the array. Moving on to slice. What does slice do? Well, it returns a copy of an array from a starting point to an ending point, and that ending point is exclusive. So that means up to, but not including. You'll see what I mean in an actual example in just a second. So let's say I have an array of A, B, C, D, E, F, G. And let's say I want to call slice on it with the number 3. Well, that's going to give us the array after C because C is the second index. So it's going to give us everything from 3 onward. If we don't provide an end argument to slice here, it's going to just automatically go to the very end. So it's going to start at 3 and slice all the way to the end. Let's see what this gives us. So logging it here, we get D, E, F, G. It's just giving us a section of this array here. Now this is not mutative at all. So actually if I come down here and log the original array, we can see that it is not mutated. The original array is still A through G. Now let's take a look at the second argument for slice. If I were to remove all of this and then just say I want the very middle of the array, by calling slice 2 and 5, what I'm saying is I want to start at 2, so 0, 1, 2. I want to start at 2 and then up 2, but not including 5. So that's the exclusive part. Up 2, but not including 5. So 2, 3, and 4. F is 5, but we don't want to include that in our slice. So this should, in theory, give us C, D, and E, which is the very center of this array. If I were to log this out, we get C, D, and E. Now we're going on to the iterator style methods. So let's start with forEach, because I think that's the simplest. I have an array here with subscribe and like please inside of it. And I'm going to call forEach on it. Well, forEach just iterates over each item in the array. So if I call the array.forEach, I have access to the item and we can run a function for every single item in this array. So I'm going to log each item in the array. And when I log and run this, you can see for every iteration, item is the one that we're on. So it goes subscribe and like, please, exclamation point. And that's what you see here. But there are actually 2 other arguments that we can pull out here. So I'm going to add in some parentheses and we can pull out the item, we can pull out the index, and then there's also an array. And if I were to log all 3 of these, you would see that index is the current index we're on. So item is obviously the item we're on. You just saw that. Index is the current index, so 0, 1, 2, 3, and 4. And then array is always going to be the array that you're calling for each on, so it's always going to be the same. It's always going to be the array. So saving this, let's run it. We're going to see a lot of output. For the first one, the item is subscribe, the index is 0, and then you see the array, and 1, the array, and so on. You get the idea. Next up is find, and find is really helpful when you want to find something in an array. Well, actually what ends up happening is it finds the very first instance of an item in an array. Otherwise it returns undefined. So if you have an array, let's say we have an array called names with Tyrese, Candace, Joe, and Sky in it, and we want to find the very first name with the letter O in it. Well, we can call name.find, and for every name, I'm using n to represent name. If n.includes the letter O, then it will find that and assign it to this value here. So let's log this out and see what it gives us. It gives us Joe, because if we look in here, the very first name in this array that has the letter O is Joe. Now, something to keep in mind is that this is not mutative. So if I were to do this and then log names, you could see that the array has not been modified in any way. And one more thing I want to demonstrate is if I were to try to find the first name with the letter Z in here by adding in and including Z to our find function, you would see that since none of these names include the letter Z, if we were to log this out, it would give us undefined. So it's either going to find an item, and if the item doesn't exist in the array, it's going to give us undefined, which is slightly different than the next one we're going to talk about, which is findIndex. findIndex is basically the exact same thing as find with two distinct differences. Instead of returning the item that it finds, it's going to return the index. And instead of returning undefined if it doesn't exist, it's going to return -1. So if I replace find with findIndex here, this will end up logging -1 because there are no names in here with the letter Z. Now, if I were to go back to the idea of looking for the letter O, let's see what it will give us. It logs 2 because the first one with the letter O is of index 2. So 0, 1, 2. All right, let's talk about sum. And I'm not talking about sum as an S-U-M, I'm talking about sum as an S-O-M-E. Sum allows us to find whether or not some of the items in the array pass a given test. So kind of like with find, we give the find function a test and it gives us back the first item that passes that test that we give it. Sum returns a Boolean. It's going to return true if it finds at least one item in there that passes the test. And it's going to return false if none of the items pass the test. So let's say we have an array of grades, and all of these grades represent a grade, obviously. And we want to see if any of these are a failing grade. So we can say const failed. And in the United States, at least, a failing grade, I think, is below 70. So we can use grades.sum. And for each grade, we want to check if grade is less than 70. If we find any that are less than 70, then failed will be true. So let's console.log failed, and we see true because there is one value in here lower than 70. Now, if I change that to 78, we should see false, and we do. Now, this next one is very similar to sum, but instead of checking sum or at least one, it's going to be every single item in the array has to pass. So we're talking about every. So let's get rid of these examples, and I'm going to clear out my console and look inside of here. I have two arrays. I have one called evens, which contains 2, 4, 6, 8, and 10. These are all even numbers. And then I have oops, not all evens, which is 2, 3, 4, 6, 8, and 10. So there's one odd number in this right here. So I'm adding in a function here called isEven, which takes a number and then determines whether or not that number is an even number. And I'm going to console.log evens.every is even. So in other words, is every single item in this evens array even? If it is, it's going to be true. If any of these are not even, it's going to return false. Let's see what it logs. It logs true because each and every single one of these is even. But what if I were to change this to oops, not all evens? Log that. We can see false because there's one item in here that is not even. Okay, the next one is one of the ones I use more often than probably any other array function, which is filter. And what filter does is it allows you to give it a test. So you pass in a function, and any items that pass that test will be included in the array that it returns. So it is not mutative. It's not going to mutate the original array. It's going to return a new array with all of the items inside of it that pass a given test. So I kind of want to take from the previous example here and use the isEven function. Then I'm going to grab an array of numbers here. And we know that 1 through 10, only half of these numbers are going to be even. So I'm going to call filter on nums and get all of the even nums from that. So I'm saying even nums is equal to nums.filter, and I'm passing in is even, the same test that we passed in the previous example. And I am going to console.log both even nums and nums just to show you that it does not mutate. So the very first one is an array of all of the even numbers in this array, and the second one is all of the numbers, just to demonstrate that this does not mutate the original. So if you use React.js, you've probably seen this one a billion times, but now we're going to talk about map. So to describe map in the best way possible, it's basically if you can imagine, you're going to iterate over every single item in an array. Then you're going to give a function to map, and for every single item in that array, it's going to run that function with that item. Whatever that function returns, it's going to replace that item with whatever that function returns. So it's essentially mapping every single item in an array to another value and transforming it to that value using the function that you give it. So I have an array of odd numbers here, 1, 3, 5, 7, and 9. And I want to transform this array of odd numbers into an array of even numbers. So I'm calling oddNumbers.map. And for every single item, I'm mapping it to item plus 1. So 1 plus 1 is 2, 3 plus 1 is 4, 5 plus 1 is 6, and so on. This should transform it into an array of even numbers. So let's log even numbers, and I see an array of even numbers here. Now, most of these iterator style array methods, I didn't explain it in filter, but I explained it in one of the other ones, allows you to accept certain other variables as well. So what I mean by that is it also allows us to access the index on every iteration and also the array on every iteration. I showed you that in a previous example, but just know that this one, along with a lot of, maybe even all of the iterator methods, allow you to access these things as well. All right, so this next one is actually a confusing one for a lot of people. I do think this is one of the more complex ones to explain, but I'm gonna make it really simple for you in this example. So we're talking about reduce. Reduce is not mutative, same as filter and map, and many of the other ones, it does not mutate. In fact, most of these are not mutative, but I'm gonna be very specific on the ones that are mutative as we get to those. So it's not mutative, but reduce reduces an array down to a chosen value. You provided a reducer function to apply the logic, and the reducer function takes an accumulator and a current value. On each iteration, the accumulator will be the value that was returned from the previous iteration, and the value will be the current item that we are on in the iteration. Then you pass a second item to reduce, or second argument to reduce. The first item is the reducer function. The second item is the start value. Okay, doesn't make much sense until you see it in action if you ask me, but I have an array here of 1 through 10. Let's say we want to find the sum or the total of all of these numbers when you add them together. Well, we can use reduce for that. So let's take a look at what this block is doing. So I'm calling the array.reduce. Now remember, the two arguments that we're pulling out here are accumulator and value. Accumulator is what was returned from the previous iteration, and value is the current item we're on. So let's say we're on the second iteration. The second iteration value will be 2. So in this case, we're returning whatever the previous returned value was. And on the first iteration, accumulator will be the start value, which I'm passing in as 0 here, okay? So it's going to be on the first iteration, value will be 1 and accumulator will be 0. Then we're going to say accumulator plus value, so 0 plus 1. Now we're on the next iteration. Value is 2, and what was returned from the previous iteration was 1. So now we're gonna say 1 plus 2, that's 3. So now we're on the third iteration. The third iteration, the value is 3 because this item is 3. Accumulator is also 3 because 2 plus 1 was 3. Now we add those together and we get 6, and so on until it sums this entire thing up. If I were to log sum, we get 55, which is the total when all of these are added together. Now let's look at a slightly more complex example and why reduce can be really helpful. So we have the same array here, but what I want to do is actually map these values into an actual like JavaScript object. Instead of creating the sum, I want to create an object where the key in the object map is going to be the index and the value is going to be the actual value of that item in the array. So for example, if we were to process this thing out, the very first item in this array is 1 and the index for that is 0. So the key should be 0 because that's the index, and the value should be 1 because that is the value of the array at index 0. So I want to map this entire array or reduce this entire array to a map that's like that. And yes, this does also give us index and array, but I'm going to remove those here. So what does this do? We're calling reduce on the array, and instead of just simply adding the two values together, the start value, instead of giving it 0, I'm giving it an object. So the very first time that we're iterating through this, accumulator will be 1. Accumulator will be an empty object, and the value will be 1. So we're spreading out the accumulator. If you don't know what the spread operator is, just quickly Google that, or hopefully you already understand what that is. But we're spreading out the accumulator, which in this case, it's an empty object, so we're not going to really spread anything out. And we're going to add to this object index and value, so it's going to be 0, and the value will be 1. And then as we go through this, it's going to build this object out, and let's see what it looks like. And I definitely need the index for this, so I forgot. I do need the index for this because we're using it here as the key. So let's try logging that again. And it gives us an object where the array has transformed into this map, basically, which takes me to my next one, which is reduceRight. And reduceRight is the exact same thing as reduce, except it iterates backwards instead of forwards. So I'm going to clear this out, put in some code, and let's have a look. So I have an array. It's just 1, 2, and 3. I created my reducer function up here instead of passing it in directly here because I'm going to reuse it. So it's just going to take the accumulator and the value and subtract them. So instead of finding the sum, we're finding the difference between all of these. So if I were to just look at this in my head, I could say 1 minus 2 minus 3 is what reduce would give us. And then reduceRight should give us 3 minus 2 minus 1, which would be a different value. So let's run this. And you can see that the first one, if we do 1 minus 2 minus 3, we get -4. But when we use reduceRight, since it's going backwards, it's doing 3 minus 2 minus 1, it gives us 0. Okay, I think that's it for our iterator style methods. Let's move on to concat. So I have two arrays here I will paste in. I have array 1, which is don't forget, and array 2, which is to subscribe. What concat does is it allows us to combine two arrays. So if I were to want to concatenate, concat is short for concatenate, these two arrays, I could use the concat method to do so. So let's say I wanted to combine array 1 and array 2 to where it's one array that says don't forget to subscribe. Well, I could call array1.concat and pass in array 2 as the argument here. And let's see what that gives us. Combined, logging that, it gives us don't forget to subscribe. Now, what if we do it backwards? This will actually give us what I will call the Yoda version of that string. If I save it and run that, you can see it says to subscribe, don't forget. Okay, almost done here. So the next one is going to be fill. So going to make this a little bit smaller so we can see better. So fill, what that does is it allows us to fill an array with a given value on a specific range. Let me kind of show you what I mean by that. So let's say I have an array of people waiting. Let's say they're waiting in line or they're just waiting for something. Jerry, Susan, Callie, and Juan. Now, let's say I don't know, Susan and Callie are no longer waiting and we want to replace their names with an X because they're no longer waiting. We can actually use fill to do this. It might not be the best way to do it, but it's a good way to explain how this method works. So let's console.log this. And by the way, this is a mutative method. This is going to modify the original. So just to demonstrate that, I will console.log people waiting here. And in between this, I will do my mutation. So people waiting dot fill, and it takes 3 arguments. It takes the item that you want to replace your section with, which in my case is an X. And then the next value is a start value. And the third value is the end, which is exclusive. So where do you want to start replacing? Well, we want to replace Susan and Callie with X. So Susan is the 1 index, so we'll start there. And then we want to stop at 0, 1, 2, but we have to do an exclusive value. So it's going to be the next one. So 4, 0, 1, 2, 3, I'm sorry, 3. So we're going to go all the way up to, but not including the index of 3. See what this gives us. It gives us Jerry XX1. Okay, and then we have flat. And what flat does is it takes a nested array and moves up one level, basically. So let's say we have an array here called nested1 that has 1, 2, 3, and then it has a nested array inside of this. And this nested array just has A, B, and C. So it's basically what we would call in JavaScript a 2-dimensional array. So we have an array inside of an array. Now what flat is going to do is remove this level. It's going to remove all nested items up one level by default. So this is not a mutative array method. So I'm going to call console.log nested1. It's going to return a new array. So nested1 dot flat. And if I call it like this on default without passing in any arguments, it's only going to do it one level. And I'll show you an example with multiple levels in just a moment. So just to make sure that it's not mutative, I'm also going to log the second one. You can see that the second one is still a nested array, so it did not modify or mutate that original array. But the one that we called flat on, it returned a new array without that nested array inside of it. It moved it up a level. So now let's change nested to a 3-dimensional array. This array has a nested array inside of it, and inside of that nested array is yet another nested array. So we would call this a 3-dimensional array. Also, I'm not really sure I'm calling this nested 1. We should just call it nested. But what happens if we just call flat on this? I can get rid of this right here. We already proved that it's not mutative. Okay, so it moves everything up one level. So now we only have a 2-dimensional array. So it took it from a 3-dimensional array to a 2-dimensional array. But if we want this to be completely flattened to a 1-dimensional array, we have to provide in explicitly how many levels we want to run this on. So we can say 2 here. And by providing 2, we're going to say we want everything to be moved up 2 levels. And now we have a 1-dimensional array with all of those items inside of it. Okay, so this next one is very similar to flat, and it's also very similar to map. What it does is basically both of those at the same time, and what I'm talking about is flatMap. It's basically the equivalent of calling map and then flat at the same time. I'll show you what I mean. So let's say we have this 2-dimensional array here. Now everything in this 2-dimensional array is going to be one of two things, either an array of 2 numbers or an array with undefined inside of it. Now let's say we want to basically map over this array and convert this whole 2-dimensional array into a 1-dimensional array where each of these nested arrays with numbers inside of it are converted to the sum of those values. So in other words, this array should be converted to 3, this array should be converted to 8, etc. But notice that some of these are undefined. There isn't 2 numbers in some of these arrays. In those cases, what we just want to do is return that original item. We don't want to try to add 2 numbers when those 2 numbers don't exist. So what this checker function is doing is it's saying if both item 0 and item 1 exist, in other words, it's not just an array with undefined in it, we want to go ahead and return the sum of those 2 values. Otherwise, we just want to return the item. And the item will actually just be the array itself with undefined in it. If it is 2 numbers, it's actually just returning the sum of those 2 numbers. Okay, so how can we make this work cleanly without having to call both flat and map on this? We could use flatMap, obviously. So before I do that, I want to just call it with map just to show you what it looks like. So I'm going to call console.log sums with just map. As you can see, some of these are arrays and some of these are numbers. We don't want that. We want it to just all be a 1-dimensional array. We don't want some of these to be arrays and some of these to be the sums. So that's where flatMap comes in. FlatMap, if I convert that map to flatMap and then we call this again, you can see that now instead of it returning an array of undefined, it's returning just undefined. So we have a 1-dimensional array. It's a super convenient way to do things like that. Okay, getting close to the end here. Next up is splice. So splice is different from slice, even though it sounds very similar. It is actually mutative, so it is going to modify the original array. And what it's going to do is replace a section of an array with a given value. So that example that we used with fill probably would have been better to use splice, but again, I just wanted to kind of use that for that example. Anyway, splice. So let's say we have this array here, and we call it array, and it's 1, 2, 3, 4, and 5. Now let's say for whatever reason, we want to replace this particular section, so just 3 and 4, with A, B, and C. So we can use splice to do this. So what is this saying? The first argument is going to be at what index do we want to start replacing? So if we want to replace 3 and 4, we're going to start at index 2 because 0, 1, and 2. The second argument here is how many items we want to remove. So in total, since we want to remove 3 and 4, we want to remove 2 items. So that's what that 2 represents. That's the delete count. And then any number of arguments after that is going to be what gets put in that place. So we're going to essentially be replacing 3 and 4 with A, B, and C, and it is going to mutate the array. So I'm going to log array and see what that gives me. As you can see, it replaced 3 and 4 with A, B, and C. Now, if I don't want to actually replace it with anything, I just want to delete a section of an array. For example, I just want to delete 3 and 4 without replacing it with anything. I can get rid of these last 3 arguments here and just have 2 and 2. And if we log this, you can see it's just deleted 3 and 4. it did not replace it with anything. And then finally, if I only want to give it the start value and I don't want to give it an end value, it will actually splice from the second index, so 0, 1, 2, all the way to the very end. So if we run this, you can see it replaced everything from 3 all the way to the end, giving us just 1 and 2. Okay, so for the next couple ones, you're gonna have to understand what the concept of an actual iterator is in JavaScript. Actually, you don't really have to understand what it is technically. Just know that an iterator is an object in JavaScript. If you want to know more about how iterators work in detail, that would be a video and topic completely on its own. So go check that out if you want to understand what iterators are in detail, but just know that they're JavaScript objects. So let's talk about keys, the keys method. All right, we have an array here and it's A, B, C, and D. What the keys method basically does is basically the same thing as object.keys. However, it does not ignore holes in the array, and I'll show you what I mean by holes in the array. And also it does not convert the keys to strings. So if you're unfamiliar with how object.keys work, if I logged object.keys and I passed in the array to object.keys and we log this, it would give us all of the keys. Now, the keys of an array are going to be the indices. So 0, 1, 2, and 3, and we get an array with 0, 1, 2, and 3 in it. So what happens if we try to log the array dot keys? What is this gonna do? What is this gonna give us? It actually logs an object with array iterator inside of this. So you can see it's logging an actual iterator object. So in order to see the actual values of this iterator, we have to iterate over this iterator. So I'm going to put in this forOf loop here, and I'm saying for const item of the array.keys. I just want to log every single one of the items. So as I'm going through here, you can see that it is logging each of the indices. And notice that these are numbers and not strings. So it did not convert these to strings like object.keys does. Now, towards the beginning, I said it does not ignore holes in the array. Let's look at an array with a hole in it. And what that means is that one of the items is just, there's nothing here. So we're saying A, comma, nothingness, comma, C, D, all right? So this is an array with a hole in it. Now, what would happen if we were to call object.keys on this? Well, we would get 0, 2, and 3. So these are the indices that exist here. It's ignoring this hole here. But if we were to use .keys here and iterate over this using the forOf loop, you would see that it does not ignore this hole. It actually gives us the key of 1 here. So that's an interesting difference between the two. Now, next up is values, which is the exact same thing as keys, but instead of giving us the keys or the indices, it's going to give us the values. So I'm going to replace keys with values. And if I save this and log this, you can see that we get the actual values instead of the indices that get logged out right here. And whenever there's a hole in the array, it gives us undefined instead of, whatever else it could possibly give us. But I'll put in a B here just so you can see that if we run this again, it gives us B for that value. So values and keys do essentially the same thing, but keys gives us the indices for the array and values gives us the actual values of the array. Just 3 more to go here. This next one is going to be entries. So entries also returns an iterator. Now, keys gave us the keys, values gave us the values. What entries is going to give us is actually both. Let's take a look at what that looks like. So I have an array with A, B, and C inside of there. You know that if I were to call keys on this, the values of the iterator would be 0, 1, and 2. And then if I were to call values on this, it would be A, B, and C. Let's see what entries will give us. So if I were to log iter, you would know that it would just log an object here saying that it is an iterator, as we see here. So let's iterate over that and see what each of the values is inside of this iterator. So when we, oops, I keep mistyping this. Okay, so it gives us both, right? So it gives us an index and a value inside of an array for each one of these. So in the iterator, it's basically giving us an array where the first item is the index and the second item is the value. Pretty handy. So this next one is sort. Now, I saved this one for almost the very end because it's one of the more complicated ones, I think. Not really, but there's some things about it that are kind of confusing. So we're going to go over sort now. So what does sort do? Well, obviously, just by the name, you probably guessed that it's going to sort an array. Well, if you don't give it a sort or compare function, it's going to automatically try to sort it in ascending order. And if you give it something that it can't just automatically sort in ascending order, like an array of numbers or letters, it's going to try to basically serialize that into a string and then sort it that way. So if you just use the default sort, you get some pretty helpful functionality out of that, but you're not going to be able to get too much advanced functionality unless you use that compare function, which in my opinion is the crux of the sort method. So let's just start with no arguments so we can get a good idea of what this does. So we have an array of names, Shelby, Zach, Kathy, and Jose. If I were to call sort on this, and by the way, sort is mutative, so it's going to mutate this original array, names.sort, and then we call console.log names, we should see a sorted by alphabetical order array of names here. And we do. So Kathy, Jose, Shelby, and Zach, that's alphabetical order. But what if we want to sort an array in reverse? Let's look at a different array just to mix things up here. So let's say we have the ages of all of those people, and we want to sort this in alphabetical order. In reverse order. We want to sort this in reverse order. I can pass a compare function into sort, and it's going to take two things. It's going to take A and B. Okay, so just basically two items. You don't need to worry about which items they are. That's why I'm calling them A and B. I think in the Mozilla documentation, they say first and second or something like that, but you don't really care about that. You just know that it's two different items and you want to run a comparison function between them. We're going to say B minus A because that's the opposite of ascending, right? Ascending would be A minus B. That sorting function would sort in ascending order. Since we want it in reverse, we want to reverse that to B minus A. Now, if we were to console.log ages, it should put these numbers in reverse order, and it does, 33, 32, 29, and 24. So that's how you kind of give it a custom function to customize how it does the sort. But let's look at a slightly more complex example. Let's say we have an array of objects, and we want to sort this array of objects by one of the properties. And in this case, we want to sort this array of people by age so that this array of people is organized in ascending order of age. So the best way to do that is going to be to use the sort function. And in the compare, we're just going to return a.age minus b.age. So we're comparing the age of A and B and saying that we want it in ascending order. And then when we log people, we should see it ordered in ascending order of age, and we do. So actually that wasn't as complicated as I remember thinking it was, but hopefully you all understood that pretty well. Let's move on to the final one. Okay, so the final one I want to talk about in this video is going to be copyWithin. Okay, so what does it do? Well, it sort of copies part of itself into itself. So it will not change the length of the array. So according to Mozilla, I'm going to read this straight off of Mozilla. I think this is a direct quote. If not, oh well, it's very similar. If target is at or greater than array.length, nothing will be copied. If target is positioned after start, the copied sequence will be trimmed to fit array.length. So it should not change the length of the array. It's just going to copy a part of the array at a separate portion of the array. I'll show you what I mean by that. You already know we're going to do examples and all that good stuff. So how does this thing work? And yes, by the way, it is mutative. So it is going to mutate the original array. So let's look at an example of copyWithin. Let's say we want to copy C and D, so C and D, and we kind of want to paste it where B and C are so that it becomes A, C, D, D. So again, we want to take C and D, this portion of the array, and we want to paste it here. So it would be A, C, D, D. I know this one's a little bit confusing. That's why I saved it for last. So how can we do that? Well, obviously, since we're talking about it, we can use the copyWithin method. And yes, this does mutate, so I can actually just call it and then log it below the array. All right. Okay, so the first argument is the target. Where do we want to start the pasting? So the target for where you want the copy to be pasted, we want to start that at the index of 1. The second argument is where do we want to start the copy? So the first one is where do we want to start the pasting? And the second one is where do we want to start the copying? In our case, we want to start it at index 2, so 0, 1, 2. We want to copy from 2 onward. And since we're not providing the third argument, which is the end, which I could explicitly put here, which would be 0, 1, 2, 3, for because it's exclusive, but we don't need that because we're just going to the end. So it's automatically going to go to the end. You've seen several examples of that already. That's why I was comfortable just doing this example first. So let's talk about this one more time. I know this one's a little bit confusing. So copyWithin, we're starting the pasting process at index 1, and we're starting the copying process at index 2. And since we're not providing an end, it's going to go all the way to the end. So it's going to copy C and D, and it's going to copy C and D and paste it starting at 1. So it's going to be C and D pasted here. Okay, good Lord, I hope that makes sense. So we should expect to see A, C, D, D. A, C, D, D. Very good. So I want to give two other examples here, just to show you how you can kind of choose which of those three arguments to provide. In this case, I have an array here with like this video inside of it, and I'm going to call copyWithin with just 1. And what that's saying is we want to just set the target to 1. And if we don't provide the start argument, which is the second argument, it's just going to start at the beginning. And since we're not providing the end argument, it's going to go to the end. But remember, and this is why this is one of the most complicated of the array methods to just understand, it's not going to ever change the length of the array. So since we're not providing the last value, it's going to go up into the end to the point where it's not going to make the array longer. Hopefully that makes sense. So we're starting at 1. We're going to start the pasting process at 1. But since we're not providing a start value, it's going to start the copying process at the beginning. And it's going to copy as many of these items in order as it needs to, paste into here without it making it longer. What that should give us is like this. So like isn't being changed because we're not starting the pasting process until the very first, or until index 1. So here is where we're starting the pasting process. It's taking the first item, which is like, pasting it here. It's taking the second item, which is this, pasting it here. And since we don't go beyond the length of the array, it just stops. So it should give us like this. Let's take a look at what that logs. We get like this. And then finally, let's do one with all three arguments. So this was like this video. Let's do an array where it says it helps the channel. And let's set the target to 2. So 0, 1, 2. It's going to start the pasting process at the. We're going to give it 0. So it's going to start at 0. And it's going to go all the way to 2 exclusively. So 0, 1, 2. So just the first 2. So it should essentially give us it helps, it helps. So it helps, it helps. Man, I know that is really hard for me to explain verbally. But yeah, that's how it works. Hopefully these examples and the amount that I talked about it like soaked into your brain. But yeah, that's a confusing one for sure. All right, now that was quite a few, but we got through them all. Good job. If you haven't already, don't forget to like this video and subscribe, and I'll see you all in the next video.